Now we explore the outer solar system, where the giant planets live, the first of which is Jupiter. The distances between planets start to get bigger now. The shortest journey to Jupiter will be about 490 million kilometres. At light speed, that would be half an hour, and 42 seconds at warp 3. However, it will only take us 8 seconds because we are now travelling at warp 5. The biggest planet, Jupiter. This still image makes it look like it's made out of marble. But that's not solid ground. This is a gas giant. It's mainly made up of hydrogen. The outer atmosphere we can see is hydrogen in gas form. Then 50 kilometres below that, it forms liquid hydrogen, and as the pressure builds, it becomes metallic hydrogen, and only in the centre is a molten rocky core. Jupiter is the fastest rotating planet, moving at 12 kilometres a second at its equator, and the speed affects its shape. If you look closely, you can see that it is fatter than it is tall. Jupiter is also massive, in terms of both size and weight. It is so massive, it's more than 2.5 times heavier than all of the other planets combined. As a gas giant, it's also known as a failed star. The Sun also contains mainly hydrogen, and if Jupiter was 75 times heavier, it could fuse hydrogen into helium and become a star in its own right. It is the biggest and fourth brightest object in our sky. It's the king of the planets, and the ancient Greeks named it after their king of the gods, Zeus. The Romans called it Jupiter after their equivalent. The moons of Jupiter are named after Jupiter and Zeus's descendants, lovers and favourites, and there's a lot of them. 95 known so far, and the 4 largest ones are visible from Earth with binoculars on a clear night. These are known as the Galilean moons, and their discovery by Galileo back in 1610 put us on the path to figuring out that we revolve around the Sun and not the other way around. The inner 3 moons have what is known as an orbital resonance. Io goes around in half the time Europa does, and Europa goes around in half the time Ganymede does. Two of them are regularly next to each other, but never all 3 at the same time. Io is incredibly yellow. There are over 400 active volcanoes here, which makes it the most geologically active object in the solar system, and the sulphur produced gives it this strange colour. In terms of size, it's very similar to Earth's moon, only slightly bigger, and it has the highest density and surface gravity of any moon. Europa has the smoothest surface of any known solid object in the solar system. There's a crust of water ice covering it, which gives it a frosted look. It stands to reason that the largest planet should have the largest moon, and Ganymede is it. At over 5,200 kilometres across, it's bigger than Mercury, though only half as heavy. It is also the only moon to have a substantial magnetic field. Lastly, Callisto, the oldest and most heavily cratered object in the solar system. 4 very different moons. And now it's time to visit the second of the 2 gas giants, Saturn. It's another 535 million kilometres, and for us, a journey of 9 seconds. Saturn, father of Jupiter and the god of wealth and agriculture. The Romans named the 7th day of the week Saturn's Day. It's another failed star and also made of hydrogen. It is not that much smaller than Jupiter, but it's only half as dense, so there's a lot less stuff in there. It's the only planet less dense than water, only 2/3 as dense, and it's the most squashed of all the planets, 10% larger around its equator than the poles. Saturn's surface doesn't have the same patterns as Jupiter. However, there is a very strange hexagonal shape around its north pole. For a sense of scale, each side is about 14,500 kilometres long, and you could fit the Earth into that. Its most incredible feature has to be the extensive ring system. All the giant planets have rings, but this is the only one you can see from Earth with a telescope. The rings are made mostly of ice, helping them to be reflective and visible. From Saturn's surface, they stretch out from 6,600 to 80,000 kilometres, but never more than 1 kilometre thick. Along with the incredibly impressive rings, there are at least 146 moons and numerous moonlets. The first 7 identified were all named after Titans, seeing as Kronos is the Greek equivalent of Saturn, and he was king of the Titans. With the amazing high-definition pictures sent back over 1 billion kilometres to Earth, we can actually see what they look like. So first, we head out for that small moon, and we come to Mimas. Mimas has the second largest crater of any moon when compared to the moon's size. It's so large that scientists are surprised the impact didn't shatter the moon. At about 140 kilometres across, it's 1/3 of Mimas's diameter. But Mimas survived, and now some people think it resembles the Death Star. Next out is Enceladus, also a smaller moon at about 500 kilometres across. It's mainly rock covered in fresh, clean ice. There is a large body of water underneath its icy crust, and near the South Pole, cryovolcanoes shoot out water vapour from geysers. Most of the vapour shoots into space, but some falls back down as snow and forms the icy crust, making it one of the most reflective bodies in the solar system. With its global ocean, unique chemistry and internal heat, Enceladus has become a promising lead in our search for worlds where life could exist. Tethys is next, and they're getting bigger now at about 1,000 kilometres across, but it's the least dense of all the major moons in the solar system. Tethys has the largest impact crater when compared to its size. It's named Odysseus, and it's 400 kilometres across. Dione, of similar size to Tethys, is equal parts ice and rock. The light streaks which can be seen on its surface are ice cliffs. It orbits at about the same distance that the Moon does around the Earth, but takes less than 3 days to go around. Normally, moons are more heavily cratered on their fronts, where they're more likely to hit objects as they travel, but this is the opposite with Dione. It's been theorised that a particularly big impact must have swung Dione around. Rhea is 1,500 kilometres across, which gives it a surface area about the size of Australia. It's a great example of what happens when rocks smash into a bigger rock in space. Titan, as the name suggests, is rather large. It's 5,100 kilometres across, and only just smaller than the largest moon, Ganymede. It is the only moon known to have a dense atmosphere and the only place other than Earth to have stable bodies of water. Its atmosphere has a super-rotation, meaning it rotates faster than the moon itself, and is made up mostly of nitrogen, leading to methane and ethane clouds. Underneath the atmosphere, there's wind and rain and seasonal weather. There are seas and lakes and dunes. The methane cycle bears a striking resemblance to the water cycle on Earth, though very cold at minus 179 degrees C, and has been described as the most Earth-like object in the solar system. It is also the furthest from Earth we've ever landed a space probe. Lastly, we look at Iapetus. It might not break any records, but it does have a very strange coloration to it. The front and sides are dark, but the back and poles are bright. Of all Saturn's moons, it is the only one to have an elevated orbit, which means you get a good view of the ring system from it. When moons in space become holiday destinations, this will no doubt be a popular one. And that wraps up the gas giants. From here on in, we're going where only one spacecraft has ever been before.